Today we're on page 7 of our Chapter 11 notes packet, looking at phase shift or horizontal shift. For y equals a sine of x plus c, or y equals a cosine x plus c, this moves the graph c units to the left. Remember when we did transformations back in Chapter 4, all right? A plus or minus inside the parentheses meant a shift left or right. So in this case, we have a plus inside parentheses is a shift to the left. And for y equals a sine x minus c, or y equals a cosine x minus c, this moves the graph c units to the right. So a minus inside parentheses produces a shift to the right. So in the first example, we have using this graph as a guide, gets the graph of y equals 3 cosine of x minus pi over 2. All right, so we have graphed for us already y equals 3 cosine x, right? It's a cosine curve. Y equals 3 cosine x. And we want to sketch the graph of y equals 3 cosine of x minus pi over 2. Well, the minus pi over 2 inside the parentheses means we're going to take each point and shift it to the right pi over 2 units. Right? So let me start here, and if I shift to the right pi over 2, all right, pi over 2 is one box. So if I take this point, shift to the right, mark the point. I'll take this point, shift to the right, pi over 2. Take my minimum value, shift to the right, pi over 2. And then take a 0, shift to the right, pi over 2. Okay. And let's go way back to the left here. Take the point, shift over, pi over 2. Shift to the right, pi over 2. Shift to the right, pi over 2. And shift to the right, pi over 2. Okay. And now let's connect these. Up at the max, and then it's going to come back down. All right, so here we have the graph of y equals 3 cosine of x minus pi over 2. So it's our y equals 3 cosine x that has just been shifted to the right pi over 2. State the phase shift of this new graph. Well, it's a horizontal shift to the right, pi over 2. Again, given the same graph, y equals 3 cosine x, we want to graph y equals 3 cosine of x plus pi over 2. Well, the plus pi inside the parentheses means that we take each point and shift it to the left pi units. Right? While I'm here, I might as well state the phase shift of this new graph. It's a horizontal shift. Pi units to the left. Okay. So pi units to the left. Okay. Here's 0 to pi. All right. So 2 boxes would be pi units. So if I start at 0, 3, and I shift to the left pi units, this will move to here. take my next point. I'm going to continue this way, I suppose. At 0, shift to the left. Take my point at negative pi negative 3, shift to the left. And I'll go all the way to the right here. At this point, 2 pi 3, shift it 2 units to the left. I'm sorry, shift it pi units, 2 boxes to the left. Take the point here, 2 boxes to the left. The minimum point down here, shift to the left. And I think the next point is this one, shift to the left. And that's it. Now connect them all. Let me continue. I know how this finishes out. Right? Should be just like that. Okay, now what we're getting into next is writing the equation. Given the graph, come up with the equation. So before I turn to the next page, all right, if I look at this here, if I look at what I just graphed, we can write in an equation for this without the shift, right? This is inverted cosine. We could write this as y equals negative 3 cosine x. And if I go back up to the first example, I want to take my graph here that's in purple, right? And if I don't look at it as having any type of shift, okay, this wouldn't be a cosine curve, would it? It would be a sine curve with no shift, right? Because my sine curve starts at 0, 0, comes up to the max, down to 0, min, max. This is one complete cycle of a sine curve with no shift. So another equation for this would be y equals, how high does it get? 3. Y equals 3 sine x. So that's a lead in to our next section. Writing equations of trig graphs, y equals a sine b x plus c, or y equals a cosine b x plus c. To write the equation of a trig graph, you need to find the a, b, and c values. Here are our steps. Determine whether it is sine or cosine curve and whether it is right side up or upside down. Find the amplitude, the a value, the highest point on the graph. Find the period, the horizontal length it takes for one full cycle. That's the x amount from start to finish of one full cycle. Calculate b, which is equal to 2 pi over the period, and then calculate the phase shift. Remember, shift left is x plus c, shift right is x minus c. We want to write the equation of each sine or cosine graph below. And there is more than one or two acceptable equations. There's an infinite number of equations that can be written to represent a particular graph. All right. First thing, determine whether it is sine or cosine curve. All right, well, if I'm just looking at this portion, okay, we're starting at the origin, so it's definitely a sine curve. So number one here, this is a sine curve with no shift. Next, find the amplitude. How high does it get? All right, our a value is 3. How high does it get? 3. Find the period, the length for one complete cycle. All right, so here we have one complete cycle of our sine graph, right? 0, max, 0, min, 0. What is that length? So the period here is 2 pi. Next, calculate the b value. Okay, so b is equal to 2 pi over the period. And 2 pi over 2 pi is equal to 1. And then calculate the shift. Okay, well here there is no shift. So our equation now, we fill into our shell up here, y equals a sine b x plus c. So here we have y equals a sine b x plus c. All right, 3 sine b value is 1, 1x. So y equals 3 sine 1x. There's no shift, so plus 0. So y equals 3 sine 1x, 3 sine x. Now, if I wanted to write this as a cosine curve, right? What if I want to write this as a cosine curve? Well, cosine would start at 3, right? Instead of starting at 3, go to the max. It's been shifted. How much? It's been shifted to the right. What is this amount? It's pi over 2. So if I want to express this as a cosine curve with a shift, this would be y equals, so as a cosine curve, this would be y equals 3 cosine 1x, and a shift to the right would be minus, and what's the amount of that shift? Pi over 2. Okay? Now I can check it if I go to the calculator and I key in as a sine curve y equals 3 sine x. And then key in y equals 3 cosine parentheses x minus pi over 2. Okay, 3 cosine, gives me the parentheses, x minus pi over 2. Close parentheses. And so that you can see the difference between the two. I'm going out in front and I'm going to, oh, I should have used the colored one. If I change this by pressing enter, there, I want that circle there. And now press graph. Here's my original, y equals 3 sine x. And now there you see that the cosine is following right along it, right on top of it. So the two equations, two graphs coincide. It's a means of checking using the calculator. Okay, next for number 2, right? We look at this, and with no shift first, what do we see? All right, this is not starting at the origin, it's starting at -2. So this is definitely, this is an inverted cosine curve. This is an inverted cosine curve. All right. It starts at -2, so this would be y equals -2 cosine. There's no shift, so there's no plus or minus c value. And what is the length of one complete curve? Or, well, min, 0, max, 0, min. The length is 2 pi. So if the period is 2 pi, again, I like using frequency because the frequency tells me how many complete curves we have from 0 to 2 pi. The frequency, the b value, is 1, right? We have one complete inverted cosine curve from 0 to 2 pi. So our b value is 1. But if we figure out calculating the b value based on the period, it's 2 pi over 2 pi. which is 1. So this is y equals negative 2 cosine 1x. Now, as a shifted sine curve, okay, sine would have started at 0, 0. This one has shifted to the right. The amount of that shift is pi over 2, right? It's halfway between 0 and pi, so that's pi over 2. So as a sine curve, this would be y equals, if I start here, I do go up to the max, so this is 2. The a value is 2, sine, and now here's our shift. It's been to the right, so that's minus pi over 2. Next, number 3. All right, look at this. I always like to look at from 0 to 2 pi first. And if I look at this, is it a sine or cosine curve with no shift? With no shift, it's a cosine because we're starting up at here at 0, 4. So our a value, or our a, is 4. So this is a no shift cosine. So let me switch to blue. No shift cosine. Y equals 4 cosine. Now, what's the b value? All right, 2 ways you can get that. From 0 to 2 pi, how many complete cosine curves do we have? We have 1, 2. So our b value is 2. That's from the frequency. From 0 to 2 pi, 2 complete cosine curves, or 2 complete cycles. All right. Otherwise, the other way to get the b value is what is the period? What is the length of one complete cycle? It's pi, right? From 0 to pi, you have one complete cosine curve. So the period would be pi. So the b value can be found by taking 2 pi divided by the period. So 2 pi over pi is 2. So again, our b value is 2. Again, there's 2 ways you can always get that b value, either by taking 2 pi, dividing it by the period, or if you have from 0 to 2 pi, the number of complete cycles of your curve. So b is 2. So this would be y equals 4 cosine 2x, because there's no shift. Now, as a sine curve, okay, sine would start at 0, 0. Instead of starting here at 0, 0, now I have a choice here. I could go to the left or I could go to the right. If I go to the right, I'm sorry, I said right, but I'm pointing left. All right, if I'm going to the left and I follow this, okay, we go up to 4. So my a value is still 4. So we have y equals 4 sine. The b value is not going to change. That is 2. But now we do have a shift. So now I have to do parentheses x, and this was a shift to the left. And how much is that shift? Let's see. I think it's a little easier if I look at this. This would be half. That would be pi over 2. So it looks like a quarter. So this would be a quarter pi. All right. And we're shifting to the left. So to the left means plus pi over 4. Next, number 4. I'll look at this. Oh boy. Well, first off, it's a no shift sine curve, right? Because it's starting at the origin right here. So it's a no shift sine. No shift sine. Now, what's the max? Well, it is 1. So our a value is 1. So y equals 1 sine. Now, how much what's our b value? How much of a curve do we have? I'm going to do this. From 0 to 3 pi, we have half a sine curve, right? Because we have 0, max, 0. So now we would have to go out to 6 pi. We'd have to go out another 3 pi and get to 6 pi to have one complete sine curve. All right, so our period is 6 pi. So now b would equal, again, just using the formula from up above, b would equal 2 pi. Did I go up by 2 pi divided by 6 pi? 2 pi divided by 6 pi is pi over 3, or 1/3 pi. I'm sorry, it's just 1/3. All right, so our b value is 1/3. So we have y equals 1 sine 1/3 x. That was our no shift sine curve. Now, to write this as a cosine curve, all right, cosine should start at 0, 1, but this has been shifted over. And again, I could either shift to the right, or I could think of looking at this point here and shifting to the left. Right? So there's always more than one equation depending on how you want to look at your shift. Okay, well, how much is this? What is the length of this? Well, I got to be thirds, so it's going to have to be between pi and 2 pi would have to be 3/2, right? It'd have to be 3/2. So if I'm looking at this way, it would be 1.5, 3 pi over 2. Okay, but if I start off here and I follow this for cosine, starts and then goes down. Okay, so we're starting at 1. So, or a cosine, a value is still 1. B value is 1/3. That's not going to change. The B value would not change. But now the shift. This is a shift to the right, so that would be minus. And the amount of the shift is 3 pi over 2. Some more practice on the next page. Number 5. Okay, I look at this and it's not starting at the origin, and the point here, this minimum, that also is not on the y-axis. So whether it's sine or cosine, both have shifts. Right? They both have shifts here. So let's choose. What do we want to do first? I don't know. I see this as an inverted cosine curve. All right. I'm looking at this point. Instead of being here at 0, -1, it's been shifted this amount. What is this amount? Well, this is pi, and this is broken up into 4 intervals. So this must be pi over 4. Okay, so this is pi over 4. So I'm writing this as a cosine curve first, a shifted cosine curve. And if I go, let's say here, I'm going to go, I don't like this too much. Okay, so this does look like from here to here, that is one complete cosine curve, right? So the b value is 2 pi. If I extend this a quarter more out here, that'll give me one complete inverted cosine curve. So from here to here is 2 pi, so our b value is 1. We're starting down at -1. So this, as a cosine curve, sorry about that, this would be y equals negative cosine 1 x, and this is a shift to the right, so that would be minus pi over 4. Now as a sine curve, let's see for sine, okay, I'm looking at this point. Instead of starting here at the origin, right, it's been shifted in this direction. So it's been shifted to the left pi over 4. So as a sine curve, this is y equals negative sine parentheses x plus pi over 4. Not too bad then. All right, and number 6. Again, there's both shifts here. As a cosine, I'm going to start with sine. As a sine curve, all right, instead of starting here at the origin, it's been shifted. And the amount there, again, is pi over 4. So it's been shifted to the right, pi over 4. From 0 to 2 pi, or let's see, what's the length for one complete sine curve? The length for one complete sine curve. Let me go from here to here. Okay. Yep. That's 2 pi. So if I just go over, yep, this is 2 pi. So we have one complete sine curve from 0 to 2 pi. So our b value is 1. And how high are we getting? Our maximum is 2. So this would be y equals 2 sine, b value was 1, x, and our shift was to the right, so minus pi over 4. Now if we see this as a cosine curve, again, there's two ways. You can either go down here at negative 2 and see a shift to the left of pi over 4, or we could go up here to positive 2 and see this as a shift to the right, 1, 2, 3 pi over 4. Okay? If I'm starting here at positive 2, then my a value stays the same, positive 2, as it did for the sine. So as a cosine, it would be y equals 2 cosine x minus 3 pi over 4. Or, if I'm looking at the other one, as a left shift, then it would be y equals, and this is for this one here, y equals negative 2. Because we're starting down at negative 2. Y equals negative 2 cosine parentheses x, and a shift to the left would be plus pi over 4. Okay. So that's it for given the graph, coming up with the sine or cosine, the equation of the graph in terms of sine and cosine. Now our last thing for today is the tangent graph, y equals tan x. It's graphed for us already, okay? If we go to the calculator, and I think maybe I'll probably just have you do this tomorrow in class, but let's just fill in the notes to complete this. This is what the graph of y equals tangent x looks like. We have what we call these vertical asymptotes here. I'm going to draw these in red. This pen is dying. And you've heard we've mentioned the term asymptote before. This asymptote is at pi over 2. This one negative pi over 2. And here we have it 3 pi over 2. And why is that? If we look at the unit circle, just a quick sketch of the unit circle, 1, 0, 0, 1, negative 1, 0, 0, negative 1. and our radian measure 0, pi over 2, pi, 3 pi over 2. Okay, remember, tangent is sine over cosine, so at pi over 2 radians, sine over cosine, 1 over 0, that's undefined, right? Tangent's undefined here. So that's why we have this vertical asymptote on the graph, all right? This graph approaches this line but never reaches it. And then also at 3 pi over 2, tangent is undefined. Negative 1 over 0 is undefined. So the same at 3 pi over 2, and then also at negative pi over 2 and negative 3 pi over 2. The interval or the period for one complete tangent graph, this would be considered one complete cycle of a tangent. This is from negative pi over 2 to pi over 2. That would be a length of pi units. Our domain, it's all real numbers except for these asymptotes, except for these values of x. So our domain would be all real numbers except x equal to plus or minus pi over 2, plus or minus 3 pi over 2, plus or minus 5 pi over 2, so odd multiples of pi over 2. The range, these keep going upward, right, and downward, lowest points, highest point. The range is all real numbers. The amplitude, how high does it get? It actually doesn't have an amplitude. There is none. The period, that was what I mentioned before. The period is a length of pi. And the equation of the asymptotes above, they are x equals negative 3 pi over 2, x equals negative pi over 2, x equals pi over 2, and x equals 3 pi over 2. I'm sorry again, I have another long video, but thank you.